Hello, I'm Martin Looker from Silicon Labs. Welcome to this dev lab where we'll be using Adafruit's RGB LED Matrix array and integrating it into both a Bluetooth and a Matter application. We'll make use of the driver for this board from the third-party hardware drivers extension for Simplicity Studio. Okay, Google, turn on test. Let's integrate the LED matrix into a Bluetooth application. Before we create the Bluetooth application though, we'll need to create a bootloader application to boot it. You can do this from Simplicity Studio by visiting the launcher perspective, select a connected board. I have an MG24 Explorer kit connected here, and do a filter for app loader. And the bootloader that we're looking for is this one, Bootloader SoC Bluetooth App Loader OTA DFU. And click the Create button to begin the process of creating the bootloader app. In the new project wizard, make sure that you're happy with the project name. I like to append the board number to my project names, so if I create the same project for different boards, I can distinguish between the different applications. Once you're happy with the name and the file location, click Finish to create the project. To build the bootloader, click the top level folder in the Project Explorer and use the Build button that has a hammer icon on it to begin building the application. When the binary is built, you'll find it underneath the binaries folder in the Project Explorer, and you need to select the .s37 file, right-click it and choose Flash to Device. Because I'm working with a bootloader and a separate application binary, I'm going to erase the whole chip at this point to make sure everything is clean, and I can then program in the bootloader. We already have a Bluetooth application that allows a light to be turned on and off remotely. So we'll use that as the starting point for our application and add support for the LED matrix. To create the starting project, return to the launcher perspective in Simplicity Studio, make sure your board's selected, and under Example Projects and Demos, you can do a search for Blinky. And here we find the Bluetooth SoC Blinky example. And just like we did with the bootloader, we need to click Create to begin the process of creating the project. Once again, I've appended the board number to the project name in the new project wizard, and I can click Finish to begin creating the files. When you create a new example project, Simplicity Studio will automatically open a README file for the example, showing you how to use it and describing some of the features within the application. Let's explore how this application works without making any modifications to it. First, we need to build it. So once again, I'll select the top level project in the Project Explorer and use the hammer icon to begin the build process. With a successful build, I can now open up the binaries folder, select the .s37 file, right-click and choose Flash to Device. This application binary should sit alongside the bootloader, so I'm not going to erase the whole chip this time. I'm simply going to use the Program button to flash the new binary alongside the bootloader. EFR Connect is Silicon Labs' Bluetooth application that you can use to work with Bluetooth devices. If I select the demo option in the lower left and choose the Blinky part of the application, it will search for an example Blinky device, which is the one I'm running on my Explorer kit on screen. If I select the Blinky example, it will connect to the device, and we can turn the light on and off by tapping on the screen. So LED 0 here represents the state of the light, and as I tap on the screen, you'll see it turning on and off. We can also monitor button 0 from this application. If I press button 0, we'll see the button be highlighted to show the buttons down, and we can release it again as well. So the LED on the board isn't particularly bright or noticeable, and that's one of the reasons why I want to add the LED matrix to this application to make a much more convincing light. The EFR Connect mobile application is available from both Apple's and Google's app stores. Driver support for the LED matrix is available as part of the third-party hardware drivers extension for Simplicity Studio. You'll need to clone or download this repository, and you can follow instructions here that describe how to install it. Alternatively, we have a quick start video that shows how to get started with this extension. With the extension installed, I can add the driver as a software component into my project. To do this, you need to open up the .slcp file and go to the Software Components tab. The extension is provided as evaluation quality, so to allow it to show up in the software components, you need to drop down the quality box and make sure evaluation is selected. To find the driver, I can search for the start of the part number, which is IS31, and we can see the driver software component here. But before I can enable that, I need to select the third-party hardware drivers at the top level and enable the extension. The enabling of the extension and the evaluation quality filter only need to be selected once for each project. Once I've enabled the extension, I can select the device and use the install button to install the driver files into the application. And this will also configure default settings for the pins that make use of the I2C communications to this device. When you install a driver as a software component, a third-party hardware drivers folder will appear in your application. And if you dig down through the subfolders, you'll find the header files that contain the APIs to work with your device. So we can see there are initialization functions here, functions to enable the device, and functions for drawing in the screen, drawing a pixel, filling the display. I've written some code that will draw a light bulb to the LED matrix in either an on state or an off state. To obtain the code, you'll need to visit the Silicon Labs Training Examples GitHub repository and download or clone it. If you use the code drop down, you can use the URLs or the command lines to clone with your favorite client. If you have GitHub Desktop, you can use GitHub Desktop, or alternatively, you can simply download a zip with all the files in it. If you follow this last option, make sure you unzip the files locally before continuing. The files that you actually need will be found in a DevLab Adafruit 13x9 RGB LED Matrix folder within the files that you download. So here I am in the Training Examples repository that I've cloned to my local PC. So I need to go into the Adafruit folder for the DevLab. And if I go into the common folder, I'll find the two source code files that we need to bring into our project. For this Bluetooth project, I can simply select them both, drag them over to the top level project in the Project Explorer, and select copy files to copy them into the project folder. Let's take a quick look at the header file for this. So this is a straightforward header file. There are three function prototypes that are made public here. An initialization function that is used to initialize the device using the device's APIs. There's a light set function, and if you pass true into it, it will draw a light that is on. And if you pass false in, it will draw a light that is off. And also, if you want to monitor the state of this module, there's an Adafruit light get function that you can use to retrieve the current state of the light. So let's take a look at some of the detail in the .c file. We begin with a few hash defines. The columns and the rows define the size of the matrix that we're going to draw into. And I also have some colors defined here. So colors for this particular device using this driver are defined using an RGB 565 definition. So I've set some colors up here, and what I noticed on this particular array board is that the red channel seems to be somewhat brighter than the blue and green channel. So I've reduced the red values somewhat here. I also have a couple of constants that are an array of strings that I'm using to draw the bulb in the on or off state. So where there's a G, it will be drawn in grey or a dim white. And where there's a W in the on one, it will draw a white value to that particular pixel. We also have a status value that determines whether the device has been initialized correctly or not, and an internal value that holds the state of the light. When this is true, the light is on. So the initialization function makes use of the APIs first to initialize the communications to the board. And then we need to set up some LED scaling for general brightness, set up a current, and both of these are set to the maximum for the maximum brightness that we can get. And we also need to bring the board out of a sleep state by calling the enable function. We then initialize the display into the default state, which will be off, to draw on the screen. The light set function then checks that the board has been initialized correctly, and then it loops through the rows and the pixels in the arrays that define the images. If we're in the true state, or we're trying to switch to the true state, it will pull the character out of the array. Similarly for the off state. And then there's a simple switch statement here that will figure out a color from whatever letter it's found in those character arrays. And then the pixel is drawn onto the display using the X and Y and the color that we've determined. And finally, because this data gets buffered, we call the show function to update the display itself. And then we may keep a record of the state so we have it available. And the get function simply returns the current state of the device. Now that we've taken a look at the drawing module, let's integrate it into the main module of the application, which is app.c. The first thing we need to do is add the include file for our drawing module. Next, I'm going to initialize the drawing module. This app init function is the main initialization function at the application layer where you can add your own code. So let's add it here, ready to use. So next we need to turn the light on and off when the commands come in over Bluetooth. This SLBT on event function is called whenever a Bluetooth event takes place and is surfaced to the application layer. And in here we have a GAT server attribute value case. This is an event that happens when an attribute is written to. And if I scroll down a bit further, we can see where the LED on the Explorer kit board is turned on and off. So we need to replicate that for our LED matrix. And we can now save the file. And now I'm ready to build and flash the updated application in the same way that we did with the original Blinky app. So I'll select it in Project Explorer and hit the build button. And I can program the updated binary by selecting the .s37 file, right-clicking, choosing Flash to Device. The bootloader that's in there is compatible with this, so I don't need to erase. I can simply program my updated binary into my Explorer kit. So let's turn on the board and see it in action. So by default, this displays the light in the off state. Let's go into the demos and choose the Blinky and reconnect to my device. And let's turn it on and off. So that's a lot more visible than the small LED that we have on the Explorer board. So we've successfully used our LED array to create a more convincing light for our Bluetooth application. Now I have a board and some software to create a more convincing light than the small LED that's on the Explorer kit board. I also want to integrate it into my Matter Light application. Just like the Bluetooth application, we also need a bootloader for Matter applications, so we'll start by creating that. If you return to the launcher perspective in Simplicity Studio, select your attached kit and do a search for 1MB. The bootloader that we want is this Bootloader SoC internal storage single image on a 1 MB device. And just like before, we'll click Create to begin the process of creating the project. As with the other example projects that I've created, I've appended the board number to the default project name, and I'll click Finish to create the project and files needed for the bootloader. Building this is the same as before. I'll select the top level folder in the Project Explorer and click the Build button to begin my build. Let's locate the .s37 binary file from the binaries folder and flash it into my Explorer kit board. Once again, this is a new project. I'm putting in a bootloader. I'm going to put an application alongside it. So before I program the bootloader, I'm going to erase the whole flash. And now I can program my bootloader into the device. To access the Matter examples and the files needed to build Matter applications, you'll need the Matter extension for Simplicity Studio. You may have already installed this with your Gecko SDK, depending on how you did the installation, but you can check it by going to the Install button on the toolbar window, clicking on Manage Installed Packages, and then go to the SDKs tab. So you can see here under my Gecko SDK 32-bit and wireless MCUs, we can see the Silicon Labs Matter extension that I currently don't have installed. So to make sure this is installed, I can click the Install button. You'll need to restart Simplicity Studio after installing the Matter extension. Once you've done that, you can return to the launcher and the example projects and demos. And if you tick the Matter filter, you'll find many different Matter examples that you can make use of. The one that I want to use today is the Matter SoC lighting over thread example. And just like we've done a few times now, clicking the Create button will begin the process of creating the application. I've appended the board number to the project name once again, and I'm clicking Finish to create the files. I now need to repeat the same process we used for the Bluetooth application to add the driver into the project. So I need to open the .slcp file, it's already open here, and select the software components and enable evaluation quality components to be displayed in this interface. Next, I can search for the driver that I'm looking for. And the first thing that I need to do is select the top-level third-party hardware drivers and enable the extension. And with the extension enabled, I can select the driver and use the Install button once again to bring the API files into the project. In the Matter example, the include files and the source files are kept separately in the application. So let's start by copying in the include file from my cloned training examples repository. So once again, I'll go into the DevLab Adafruit folder and then into the common folder. And I'll begin by dragging the .h file to the include folders. So you can see it's now present in the include folder. And I can then do the same with the .c file, this time dropping it onto the src folder to bring that into my project as well. So I now have my header file and C file in the appropriate folders for this application, ready to make use of them. So now let's go into the code and do what we need to turn our LED matrix on and off, along with the LED on the board. This task.cpp file is where this takes place in the Matter application. First, we need to add the include file for our module. The initialization of the app-task module takes place in this init function. And here we can see where the LED is initialized and also the initial state is set using this value from the light manager. So I've simply replicated these calls to manipulate our matrix. The action initiated function is where the LED light is turned on and off. So once again, I've replicated that for the matrix array. With those changes, we can now save apptask.cpp and build our application, selecting the top level and using the build icon. Now we have our binary built, we can flash it into the device alongside the bootloader. Once again, I need to keep the bootloader, so I'm not going to erase the whole chip, I'm just using the program button. I want to introduce my device into a Google Home network running from my Nest Hub. All of our example Matter applications come with a test certificate, which will need to be enabled in the Google Home Developer Console, if you've not already done this previously. You can begin by creating a new project, then select Create a New Project. Give your project a name and then select the Create Project button. As this is a Matter project, we next need to add a Matter integration. Click the Next Develop button to move past the introductory screen, and again the Next Setup button to move past the checklist. In the setup screen, you need to give your product a name, so I've called mine Scilabs Lite, and you need to select the device type from the drop-down, which will also be Lite. To make use of the test certificate, we need to enter a vendor ID and a product ID, and we can obtain these values by opening up a terminal application running at 115/200 baud, 8 data bits, no parity, 1 stop bit and no flow control. Once the terminal's open, if you press enter, you'll receive a Matter CLI prompt, and type config here to get information including the vendor ID and the product ID. So the vendor ID is already set correctly in our console, so we just need to enter the product ID to complete this step. The next screen is optional. It allows you to place some product images in here, but we can just accept the defaults and click Save. The test certificate is now registered with Google Home, so we're good to commission, but we will need a QR code before we can do that. If you're running on one of our Pro kits, then the QR code will be displayed on the LCD screen. If you're running on one of our kits without an LCD screen, you can obtain the QR code from the console in a similar way to the way we got the product ID. The command we need to issue is onboarding codes space BLE, and in there you'll find a URL that you can enter into your browser. So I'm now displaying the commissioning QR code, and I'm ready to commission my device into the network. The device indicates that it's looking for a network to join by briefly flashing LED 0. This indicates that it is advertising on Bluetooth looking to set up a network. When my phone connects to the device to exchange the thread network information, it will flash more rapidly, and then it will come on solidly once the device is fully in the network. So I'm now ready to scan the QR code and begin commissioning the device. I need to choose the application that I want to associate it with, Google Home in this case, and agree to add it to my Google account. The LED is now flashing more rapidly, showing that a Bluetooth connection has been formed and the thread information is being exchanged. When the light comes on solidly, that indicates that the device is in the network. I'm just waiting for my phone to finish up the connection. So I can now click the Done button. I need to assign a room for this device, so I'll choose Desk. And I need to give the device a name. Let's call it Test. And it'll just then complete the setup of the device. I can now go into my lighting interface and go into my desk room. And here I can see my new test device. So I can use my phone to turn it on and off. And I can also use voice commands. Okay, Google, turn on test. Okay, Google, turn off test. That brings us to the end of this dev lab, where we've integrated Adafruit's RGB LED Matrix into both a Bluetooth and a Matter application, making use of the third-party hardware drivers extension for Simplicity Studio. Thanks for watching. Okay, Google, turn off test.